The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Maunaloa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dan started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont, from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, December 5th, 2024. We have Kilauea and Maunaloa both calm at the surface, but Kilauea has been ramping up a little bit over the last couple of weeks. However, Maunaloa is celebrating her 2-year anniversary of the main phase today, so we'll get into that a little bit too. So that's what we're talking about today. How you doing, Dane? How your last 2 weeks been? How was Thanksgiving?
Yeah, Thanksgiving was good. Good to be able to take a little bit of time and everything, but nice to get back into it and check up on the 2 volcanoes and go back revisit a little bit on Maunaloa. Some of the stuff we haven't gotten really to talk about on the stream all that much in depth.
Yeah, awesome. And we have Lou producing for us up here in the corner today. And unfortunately, we do not have our ASL interpreters, but we will miss them as always. Anything you guys want to touch base on here before we get into it?
No, I'm good. It was fun to watch all the videos today and yesterday, kind of going through the eruption. We lose sight, we forget a little bit about how much footage there was. It was pretty amazing. It'd be a good show.
Yeah.
There was a lot going on. Yeah, and I was even forgetting things that I had seen before. So
yeah,
right.
You dropped one for me, Phil, that I was just like, oh yeah, that actually happened. I forgot we actually did something like that. Completely out of the mind. So yeah, nice to go back. But if anybody has any questions, we're going to be doing 2 parts. First part's going to be the update on Kilauea. So if you have any updates about the current situation on the ground, this would be the time.
Sounds great. Thanks for leading that and collecting those questions, Zane. So let's get our screen rearranged here. And let's get ready for our summary. Aloha, everyone. This is our Hawaiian Volcano summary for December 5th, 2024. Kilauea's earthquake rates have steadily increased over the last 2 weeks to where now they're about double what they were 2 weeks ago at the start of the month. These earthquakes have occurred mainly underneath the summit and upper East Rift connector, but more so in the Middle East Rift near the recent eruption site at Nāpau Crater from September earlier this year. We have had other earthquakes in the area, including a deep one in between Maunaloa and Kilauea, down at the base of the volcano, base of the island, in fact. And a deep earthquake still continued from Pahala as magma feeds into the area, and we also are seeing adjustments underneath Kilauea itself, all these blue dots visible right in here. So earthquakes are picking back up on Kilauea. We have satellite images that show that the volcano is inflating, largely in this area south of the caldera and in the caldera itself too. And our instruments on the ground are also reflecting that. So our tilt meter at the summit in blue here is showing inflation as the ground tilt is increasing. But the green line at Puʻuʻōʻō crater is showing the opposite, a deflation. So the ground is deflating over there. In more detail in between, we have the Upper East Rift connector by the escape road here. This one is the green component that has been showing the signal of inflation of the recent reservoirs created by recent dikes in the last year. But further over to Puʻuʻōʻō crater, that main component that shows what's nearby in a rift is decreasing, but it does pick up inflation from that eruption site to the west. So similar to what we've seen prior to the slowdown last month, overall on Kilauea summit, the caldera continues to expand north and south, getting wider as the volcano fills with magma underground and swells, rising and spreading both. Down at the Middle East Rift Zone at Puʻuʻōʻō crater, we see a much different effect. We see a lot more of an accordion reaction as the volcano is feeling the pressure from further away, moving a little bit and then relaxing after those pulses of earthquakes occur and magma is able to redistribute within that East Rift Zone. So that's the story in Kilauea. It's building back up, but nothing is imminent yet. We will just keep an eye on Kilauea to see where this leads us. While in Maunaloa, it's been fairly quiet. This is a map of the earthquakes for the last week on Maunaloa summit. And you see hardly any events at all, and the ones you do see are very small background events through here. If we look at the whole last year and examine depth versus time, we can see that most of our earthquakes are in that shallow part of the volcano. We are having a few deeper ones under Mauna Loa as well, but nothing quite the same as we saw earlier in the year, where we saw clusters of deep earthquakes, as we presume there's interaction of the volcano filling and magma feeding into it and that area below the summit. So that's the last year. For the last 5 years, it's much more clear that we have very much reduced earthquake rates today than we did prior to the eruption in 2022. So we're still in an expected recharge phase of the volcano with no surprises here. That typical pattern as expected. And at the summit of Maunaloa, we can see that the volcano there is also still spreading, but at a slower rate here than it has in previous times. As we are celebrating the 2-year anniversary of Mauna Loa's main phase, it's worth remembering the impact that had on us 2 years ago. Here's an image from Harry Durgan of the flow over Hilo Bay. And just one short clip that I'll play here just to remind us of where we were 2 years ago. You can check our full update for more information on this 2022 anniversary. And that's our Hawaiian Volcano summary for this week. All right, so let's move on to our hazard summary. And the main hazard right now is just the gas as usual. So we'll come back to our VMAP, VOG Measurement and Prediction Project from UH Manoa. And a forecast today looks as such. There's not a lot to see because there's not a lot of gas coming out of the volcano. We're looking at about 60 to 70 tons of SO2 per day, which is a lot if you compare it to a factory emissions. And if you're a sensitive person nearby and it's coming at you, it's still a lot. But in relative terms, this is background for Kilauea volcano. So there's relatively low impact compared to what there can be on the island. And to illustrate this, we'll just quickly go over to purple air and see how much green we have across all of our islands here. And occasionally you have a few other stations that pick up some extra readings, but overall pretty good. Turning to our earthquakes, we'll look first at, well, let's see what happened here. This page is not quite doing what I thought. Okay, so let's go to our recent earthquakes and let me reset this here. Let's go back to our satellite and let's turn to Hawaii first. And let's make sure we're looking at the past 7 days here. Okay, so here's the last 7 days of earthquakes across Hawaii. Oh, I'm actually in the wrong spot here. But we'll look at this first. So here's all the deep Pahala events, all the earthquakes on Kilauea, and you see some earthquakes on Maunaloa as well as some other settling events. You see some on the Kona coast, some under Mauna Kea. And we actually had one over here between Molokai and Oahu over here. So since we're on this map first, we'll turn to that. That one was a 3.5. And because it was so close to Oahu, it was felt by many people, receiving almost 900 felt reports on the USGS website here. There's a map of where that earthquake was felt. You see all the way to Oahu there. And USGS, in fact, did release a statement about this earthquake here. On December 3rd, that the earthquake occurred 5 miles below sea level, was widely felt, but no effect on either volcano, and it was caused by the bending of the crust beneath the islands. So one of these flexure or settling earthquakes, as we've sometimes called them before. So that's that's one of the events we have here, and let's cycle through some of the others that US just put out. We did have on Saturday the 30th of November a 4.0 earthquake at 8:40 a.m. That was 11 miles west-northwest of volcano, so closer to Maunaloa, between Maunaloa and Kilauea, in fact, at a depth of 13 miles below sea level. So fairly deep, not as deep as the Pahala earthquakes, but still at the base of the island. No impact on either volcano and unrelated to magmatic activity. So that one, let's see if we can come back to our site here. And let's see if I can, gonna have to, not sure, let's see here. I gotta come down to over here. Let's do it this way. Let's get this earthquake map from here. The USGS has currently been fixing their data streams on this website here. So I've had a few issues today as some things pop up. So let me reset it here once again for you guys. And let's come to the last 2 weeks of earthquakes here on Kilauea. Hawaii Island. All right. So there, that blue one right there is that magnitude 4.0 between Maunaloa Summit and Kilauea right there. We can zoom in maybe a little bit more. You can see it's at that blue depth as marked on the map here. So here are all Kilauea's quakes, Pahala quakes separate off to the side. And if I zoom it out all the way, we'll get to where we can see that earthquake fairly shallow between Oahu and Molokai as well. So those are our local events we've had here. Also making the news this morning was the earthquake on the mainland in California. So let me scroll back to that other earthquake map, which is here. And we can go over to California and see this event right here was a 7.0 that occurred offshore Cape Mendocino. It's a triple junction here, where this transform fault that goes off and divides the plates, and then a subducting zone, and the San Andreas fault over here. And that's the triple junction of 3 plates offshore. So even though this earthquake was fairly shallow at 6.2 miles, we can go and we can look at like these data that USGS provides. And when you see what we call these beach ball diagrams that have like a cross shape in them, that indicates a strike slip fault. If you didn't have to know that, you can come down here to the summary and say that the USGS has described the summary of this event there. So it is a triple junction. It was very shallow, and there's other details in here. But the long and short of it is, while there was a tsunami alert issued for the West Coast nearby, where you maybe don't have as much time to react, for Hawaii, they had enough time to examine the details, see that it was, even though it was fairly shallow, it was a wrong kind of motion. What you need is the earth lifting the ocean up to slosh it around. If the ground under the ocean is moving back and forth and it's not lifting the ocean at all, you can't really move the water quite as much unless the ground moving has hills. You can maybe move it a little bit, but not so much. So that's the last earthquake bit we have to report here today. We can move on to Kilauea monitoring. And for that, we have a nicely written weekly update from the USGS. They're now issuing these just once a week on Tuesdays. And this has got a lot of details in it that we can go through together here. They noted that at the summit, earthquakes had doubled in frequency from about 10 events to 20 per day at the summit only. There were short-lived flurries of earthquakes with rates of 6 events per hour. So really kind of picking back up, getting to where it wants to perhaps become a larger intrusion. Those were observed on November 29th and December 3rd. So becoming a little more frequently here. Activities clustered within Kaluapele and the South Caldera. Overall, 75 earthquakes over the last week, most below 2.1. Steady inflation on GPS and tilt, and on INSAR as well, with that 70 tons of SO2 per day as a background gas value. On the rift zone, they note 25 earthquakes, so that's been down a little bit, but they increased over the past week, averaging 25 to 60 located earthquakes per day, most below magnitude 2.5. So there actually it says similar in the Middle East rift to the previous week, 75 earthquakes during that week compared to the 75 at the summit, and mostly between Maka'apu'i and Puʻuʻōʻō, all below magnitude 2. Steady deformation. And their analysis notes increased rates of seismicity and deformation observed over the past week indicate a higher level of unrest at Kilauea summit compared to previous weeks. Seismicity reflects ongoing inflation as magma accumulates within a volcano, and nothing unusual is happening east of Puʻuʻōʻō along the lower east rift zone. So that's the weekly update we have. We're basically shifting up a gear here, but we're not quite ready to panic or anticipate anything breaking through yet. So we'll see where this leads us and how fast it takes us to get there. Looking at some of the other signals here, we have the USGS, as I mentioned, is updating some other signals. So we have some updated graphs to share with you guys today, and we also have some graphs still missing as they're in the middle of this process as we speak. So we have a new crater elevation plot. Here's for the last week in Hale-Ma'u. So even though we have INSAR, we can maybe look for any movement of the crust of the crater from this new plot. We have as well our summit and east rift tilt online. And so what's happened here is The Puʻuʻōʻō station had gone offline and has been missing for a while from this graph, but POC was put back online. And at the summit, we were actually for a long time using the UWE station, right? The original Uekahuna station. So now we're moved to the Uekahuna Digital, the UWD station. So really we have a new plot that has two new components. It's UWD and POC, compared to what we previously had was UWE and POO. So now we have a new plot. The old ones still live, but they don't show us a whole lot. And now we can switch over to see what's happening at the summit and the rift at the same time once again. So that's great. There's a month-long version will come up too. There's the 1 week version. And now we can match our higher earthquake counts and see that this was happening while there wasn't a whole lot of inflation that was very fast. It's certainly inflating steadily there, slowly, but we're only gaining 2 or 3 microradians over that 1 week time there. So not a whole lot of or maybe this is half a week time there, right? So not a whole lot of rapid gain. Yeah. Okay, so let's keep scrolling down. We look at the depth versus time. Depth versus time. So here are our deep Pahala quakes. There is our 4.0 between Maunaloa and Kilauea, and that settling earthquake there. You can see a little bit different depth than the feeder from the hotspot. And then up top here in the oranges and reds, and then slightly below there in the yellows, we see the earthquakes happening near the surface. So you see it's picked up a little bit. There have been some gaps, but overall it's higher than it was the previous week. We'll have to zoom out to take a look at that. But first, for the last week, there's our distribution pattern. We actually are interesting to note there's earthquakes happening. Let me zoom this in so you can see a little better here, right? Here's our summit region. We have our Upper East Rift connector we've talked about for a while. And we have this aseismic zone here. Maybe this is where it's filling. Here's another reservoir by Makapuhi with earthquakes as well. But today we actually see beyond the South Caldera, there's this extra little arm activating this June 2024 Southwest Rift eruption site as well. So interesting to note how the volcano is filling and starting to creak in all the spots that have been moving recently. And accommodating all this filling that's happening in this broad zone up here is the south flank here to the south having to move away. And so that's what all these earthquakes over here are. Even this one, a little bit bigger one here just south of the summit. So there is the earthquakes for the last week. And then cross-section, maybe it's a little easier to see how that settling earthquake was slightly different depth than the Pahala cluster right here. They don't actually stack right here, right? If you look at the map, Pahala is way further to the south, and that earthquake's at the furthest northwest part. But when you project it to the south, it looks like they're one above the other. So just keep that in mind when you look at this image right here. All right, that's the last week. So zooming out to the last month, here is our new summit crater elevation plot and our month-long summit and rift tilt plot. So you can see the pattern a little more clearly here. Over the last month, we're up at 8 and -4, 12 microradians in total over the last month, with a couple of deflation inflation cycles superimposed in there. And really, it's been, you see, since the midpoint of the month when earthquakes began and ramping up, that we've had this extra inflation here. So now we can really see more clearly what's going on. There it is. In this upper plot, the green is the rift zone. And this plot now, the green is the South Caldera component, whereas the blue is a Halemaumau component. So this reflects a little bit there to there, the blue lines, right? If you note the scale here, we're much more zoomed out. This is 10 microradians per tick mark. So our South Caldera component is actually inflating much, much faster than our Halemaumau component. And that would explain why we're seeing that center of inflation from the satellite over that southern area of the crater. So from that point of view, you can see that this South Caldera component started off, we'll call it at -7, and ends at, we'll call it 23. That's 30 microradians in 2 weeks here. So that is rising pretty fast over there. That's going to be the center of it, as shown by our INSAR. Here's our earthquakes depth versus time for the last month. And now more clearly, you can see this increase of earthquakes over the last 2 weeks compared to the previous 2 weeks, when there were still earthquakes, but at a lower rate. That's Kilauea background, and here's Kilauea ramping up right there. And there is earthquake counts, once again, matching up. So if I draw that line right there and I scroll up to the tilt, you see it matches the exact same timeline. Okay, zooming out to the last year. Now we look at earthquakes per week. And earthquakes per week have approached 800, 900 or so, backing off this week here, but they're certainly higher than the previous 4 weeks that we saw. We're not quite to the point we saw ahead of the September eruption, but we're building up to that, right? We're maybe at this rate that leads into that, perhaps. And this was following the July eruption, the June eruption, I should say. June eruption, July intrusion, August intrusion, September eruption here. So those are 1 year counts and earthquakes per month now for over the last 5 years. We just ended November, so that month came in similar to October at around a little under 2,000 earthquakes per month there. And we'll see we're starting off very fast here in December. And it looks like we're on pace to overtake that, and not too long, depending on if the activity stays steadily high or not. Steadily higher. All right, so as a result of the updating graphs, we now have found our updated versions of the cross Caldera distance at Kilauea summit. So here you can see there is that effect of the September eruption when the summit deflated. And since then, it's been steadily refilling, expanding north and south, getting further apart across Kilauea summit. So that's showing the magma is filling underground there. Of course, one of the caveats we've mentioned before is that where this line ends, you don't catch anything outside that ruler. So if right now we're having inflation happening south of crater rim, which is our southern station here, which we believe is happening from the satellite, then this does not capture the full signal of how much it's actually spreading. You would probably want to go all the way south to Ahua, perhaps, or even further than that. At Puʻuʻōʻō, it's a little different. Here we actually don't see the same exact pattern. Our September eruption happens right here. So if I scroll this up, that's this drop right here. Prior to that, we see this July intrusion really affecting Puʻuʻōʻō and changing things there. So that really spread the ground, opened the rift zone. That made the distance across the rift zone at Puʻuʻōʻō increase. But as we've looked before, that area, let's see here, let's come to our 2-year GPS. The 2-year GPS is being updated as well. So we have a lot of missing stations. The ones that we do have that are still here have these new tags, clean local Gypsy X, for example. So they're coming online. But the reason I pull this up is we can scroll down to one of the few stations we actually do have. It's on the rift zone. It's Puʻuʻōʻō right over here, North Puʻuʻōʻō Crater. This is an up and down component. And what we see is that the ground did rise a little bit at that point in time, but now it's actually dropping again. Right? And that's what actually matters is the ground rising or falling more so than if it's only spreading. The combination of both is what's important. So the ground is dropping at Puʻuʻōʻō even as it continues to spread very slowly there, just showing it's responding to that inflation to the reservoir at Makapui to the west. So those are the signals we have for Kilauea here today. I think we'll leave it at that. With the ground data, I did want to point out that we are pulling data from the Mounts project here. That's where that summary INSAR image came from. So we have here images for that were 12 days ending today, and then on the 23rd of November and 11th. And so let's go back through those a little bit. I can show you guys what we have here. So starting off with our current view here, right? These images can be hard to read, so a quick recap. If we see a bullseye like this, going towards the center here, we're going green to red to purple to blue. So when we look, we go green to red to purple to blue is in this direction, which is towards the radar, so the ground is rising. So this is an area of rising, a bullseye of rising right here that spreads across the South Caldera Rim. And you see extends a little bit into the Southwest Rift Zone a little bit here. Unfortunately, our satellite image does not quite let us look over to the Middle East Rift or even the bend by the Upper East Rift connector. We don't see much inflation happening down here, but we do see this bullseye over here. And there's some funny things happening in the middle here. We'll get into that in a minute, but keeping the wide view to start here. Let's go back to the previous 12 days. There it is. And likewise, you see red to purple to blue, red to purple to blue towards the satellite. So there was inflation, but it was all within the caldera there 2 weeks ago, right? With more funny things happening we'll look at in a minute. And you can see that center, even though it was focused in the caldera, did have this wing to the south even at that point, right? Maybe filling first here, and then as it's filled more, it's progressed to spread more evenly to the south. And prior to that, here is the previous iteration from November 11th, going back to the beginning of that month, where we don't really see that pattern quite at all in here. We do see more what looks like inflation within the actual pit of Hale-Ma'uma'u. So we'll have to zoom in to look at that, but one more iteration going back, and there you can see as well, very different than we're seeing today. It really has picked up. So the zoomed in versions here, here's how it currently looks. And without going through the cycles again, I can tell you this is a deflation. This is deflation. And right here in between, we have an inflation. So if it's going red or green to red right there. So this is a bump that's popping up here right on that drop-down block, down-drop block of Kilauea. And that's a very small, probably localized, but it means it's something's pushing and affecting the surface more localized there than other places. So that's interesting, especially if we go back and rewind in time. Going back, we don't see that. We mostly see deflation center, and going back, another deflation center. And similarly, going back there, right? Blue to pink to red, blue to pink to red. So deflating back at that point in time. So that's really all the signals we can squeeze out of Kilauea. I know it's been a few weeks, so we wanted to give a little extra here and make sure we're as caught up as possible. We do have a couple of visuals to share as our observations. And this is just the webcams cycling through. Here's the S2 camera looking at the recent eruption site by Nāpau Crater. You see a little bit of fume maybe time to time, but it looks like not any glow anymore, not any steam coming from the actual flow that we can tell right here. So pretty quiet out there on the East Rift. Maybe if you have colder weather overnight, maybe you can see the gas or the heat a little better, but from this particular cycle, it's not easy to see here. Maybe in this one sunrise frame here. Let's see if we can catch it. A little bit extra gas, maybe. And to the summit, the KW cam, pitch black at night up there as well. Here comes the sunrise, lighting up our crusted over lava lake with lava mush still underneath there, with all those minerals building around that oldest part of the crater crust here in the middle, right in there. Still fuming. We still see remnants of all the recent eruptions all across here. But not a lot of volcanic change to report this week. So given that, we'll move on to cover what Maunaloa is doing right now before we take a break and go back and review the anniversary 2 years ago. So right now, here's a view from Moku'a Ve'ove'o today, Maunaloa Summit Crater. Pretty quiet up there, not much to see, very clear as well. Here's our signals. We have at the summit our normal daily variations, not a lot of change, maybe slightly dropping, but very little, very slow. Earthquakes, hardly any pattern to even talk about there, just background occurrences. So zooming out to the last month, we see a little bit more of a pattern. We see a little bit more, looks like a cycle coming up and coming down. And these are hard to really interpret because we do see these several week cycles occurring on a mountain as well. It's a little more sensitive up there, apparently. Sometimes you can have Kilauea moving and it does affect Maunaloa, but to untangle that from these signals, we need a stronger signal than we're seeing here to see anything conclusive about it without further input from USGS. So there is what we have for the tilt. Nothing to really report. And earthquakes per day are quite low. This, what looks like a high peak, is actually 10 earthquakes, which is very low compared to what we're seeing in Kilauea even. So not a lot to report there. Just want to make sure that we show Maunaloa and her regular steady progress of refilling following that 2022 eruption. And along those lines, USGS is saying exactly that. And their monthly update here is the most recent one issued today for Maunaloa, which is at alert level normal, aviation green. Seismicity has been low over the last month, approximately 60 small magnitude earthquakes, most below 1.5, which is expected for the post-eruption phase and similar to the previous month. There's only minor inflation at the summit. Magma is replenishing a reservoir. They are noting the temperatures and gas levels a little bit more specifically now. I think that's cool. So now we actually show H2S averages below around 10 parts per million, and SO2 below detection, while ephemeral temperatures remain steady near 83 degrees Celsius, all unchanged from previous months. So that is really the update on Maunaloa. But while we have this USGS update here, we can just scroll down and see Hualai, also normal, nothing happening there. Haleakala, nothing happening there, it's normal as well. Mauna Kea, nothing happening, all normal. Kamaehua Kanaloa, it does note earthquakes were elevated in early November, but since has returned to low levels. So everything at background at Kamaehua Kanaloa as well. And that wraps up the Maunaloa and Kilauea section here. We will step in to talk about very briefly the Volcano Watch that was released last week, Thanksgiving week, which we took off. And here they are using infrasound as an example, showing how they might configure the computer to look for a difference in what they call the short-term average versus the long-term average. And if it sees something that's in the short-term average is much higher than the long-term average to that point, then it says, okay, that could be an eruption. It sends an alarm, which might be pagers or text messages or whatever, however the USGS implements that. So that same scenario, if you add a bunch of wind to all that, you maybe can't pick it up, right? And you can actually have a false negative occurring here as opposed to a true positive, right? Other times you might have an earthquake that actually bumps or some kind of loud noise or something like that that comes through, and maybe this infrasound thinks it's an earthquake or thinks it's an eruption, but in fact it's not. So this would be a false positive. You do have a high short-term average and long-term average here, but it's not actually fitting the pattern of the rest of the eruption here. And then our final case here, when you take this and you add a bunch of wind to it as well, and you say, okay, that wind actually makes it so you don't detect this false positive, instead of you don't detect it. Nothing happened, all good there. So these are just a little bit of insight into what they kind of math they do with their data to try to figure out how not to be staring at a computer 24/7, 365, right? Because there's something happening every single time, and it's better to have a computer back you up at the very least, especially if it's overnight or something else is going on. So pretty cool. For more information on that, you can check our website and other groups, and I don't believe that we have anything else yet.
No new one.
So we'll leave that till the next one, till next week. And with that, I'll pass it to you, Dane, and to Lou to take us through our mid section here. And
yeah, we did have one question.
Right.
So I'll get to that. You want to do that after?
Well, we can do that if you want, since we're talking, since it's right here. Huh?
So it's a simple one. I only bring it up just because you brought it up, kind of something relevant. So the question is from Cecil, asks, are ground temps up generally? And maybe pivot that to talk about, like, when might you expect ground temperatures to mean something? Maybe have
so I think
an event or something. Yeah, go ahead.
Right. Yeah, there's not a lot of great data on this, really, but what data that I have seen, you're going to get these increases very soon before an eruption actually happens, as magma is coming to the surface, right? So you're talking about hours, perhaps.
Right.
Maybe if you're lucky, you might get days. If you get the right situation, right? I'm not sure about here. Like, I don't think we've seen that here in Hawaii, but it could be that something like in a St. Helens case or something like that. Maybe you get days or weeks, but here we don't really expect it to be.
The thing, like, on the rift zone, to me, is it, you have the existing cracks that it steams up through, and maybe those have some,
increase in temperature, but it's really what you're looking for is new cracks that start steaming. Those are the really, to me are the, oh no type of thing, especially when you get multiple of them in a row going across, like the subdivision, and it's like, well, that's a problem.
Yeah, at that point it's too late. It's hit the fan. You don't need that to tell you that. But what they're looking for here is that maybe like at places like St. Helens, you actually could detect things days or weeks ahead of time. And if you have like I think it was like with the hot ponds, it was a famous scene from like Dante's Peak, where the kids are in a hot pond and like it starts boiling them, because it wouldn't happen that fast, like from 1 minute to the next, right? But if you're tracking it every month and you start seeing, it's getting a little higher and it's getting a little higher, and that's a established circulation path for the fluid, right? Because all that is above the water table on Maunaloa, so you're not going to get that same kind of thing as I described Dante's Peak, right? Mm-hmm. But if you maybe see the steam coming out and it goes from 83 to 95, we'll call it, something like that, then you might be like, okay, something hot came near the surface to allow that heat to make it to the surface here. And then maybe you might get it in advance. But like I said, I've never seen that data on Maunaloa. So great to see them measuring it, and we'll watch and see, let's see what happens the next time, and that will really give us our answer, and that'll really tell us. That's why I'm excited to see it. Because now we can actually track it and see if it does change. We haven't really seen that before.
Right.
Because even when not like this. Yeah.
Even when I was answering that question, it's like, well, based on what I've seen, because I haven't heard of anybody tracking temperatures at that level saying anything other than,
there's been all kinds of cool stuff.
The ground temperature and their stuff, and like you can settle, and a lot of the changes at the steam that we have tracked before isn't exactly changes in the magma changing, but water table, rain influencing it, and also just the ground settling and moving as well.
Yeah, that's true, right? Faults and other ground movement can change those fluid pathways, and it might change temperatures and things like that without having anything to do with magma, right? And one classic example of that here in Hawaii is the Volcano House Hotel that was built over a steam vent and had a steam room in its basement until the 1975 earthquake shifted the faults and shut off the steam vent, and now they have a just regular old basement down in there. That's not quite as exciting as it used to be, right? So
fun facts.
Still exciting, but yeah, there's an example of how even if you just see temperatures changing, that by itself is not enough. It's just one of your signals in your toolkit, and you'd have to check other things as well, right? So
right.
Yeah, we'll be curious to see Mauna Loa's next eruption, what happens with those temperatures. There have been times in the past where scientists have gone up, like, hiking up there and measured this, measured that, measuring different gas, electromagnetism, all kinds of stuff. But it's been hard to really nail anything down. And I think the key about the data we're reporting now is those gas monitors are continuously reading and reporting back to the USGS. So now I have more confidence if something actually happens. We have a full record. We can actually detect what actually happens, measure how much it is, and try to figure out why. And now it's one of these great instrumentations. Let's wait and see what it picks up, and then we'll learn more. And so yeah, it's a great little discussion about the temperatures there, and maybe we don't have any final answer, but we don't need to.
All right. Well, I will bring on Lou, and we will get into it, and we'll see you in a minute.
All right.
Hey, Lou.
Hey, did I just hear Phil's fun fact of the day? Steam room at the hotel?
Yeah, I didn't actually know that, so I was just pretending I did.
That is fantastic.
Yeah. Right. So what do you got? Do you got steam baths up at the volcano?
I wish, man. That's pretty cool. I mean, honestly, I like that. No, but I do have some pretty interesting updates today for what's been going on. Let's get into it tonight, shall we? There's a nice shot of Maunaloa since we are reaching back to the past eruption. As we know, there's a lot going on up at the park right now with the construction, and the Kilauea Visitor Center closure will close for renovation January 5th, 2025. Okay, it's at 5 p.m. That's restrooms and parking and the visitor center itself. There are other things happening around the park outside of that visitor center. Grab a ranger. They're all over the place ask some questions, go up to Kilauea military camp. They've got information up there. We do have some alerts and conditions. Nāpau Crater and campground is still closed. I did ask about that earlier. There is no messages or anything on when that's going to open up. I got a question on Monday, actually. Somebody asked me about that. People are anxious to go hiking. Construction closures and delays. I just covered a little bit of that. Section of Crater Rim Crater Rim Trail closed for nanny nesting. That's still going on up there. Till I've not seen any new goslings. And the yellow jackets are.
I have. They're all over Waikoloa Village Golf Course.
Yeah, right.
There's plenty of photos of them again.
The last time, 2 weeks ago when we were up here, we had the Maunaloa Road that was closed for daytime use due to surveying and drilling that's going on up there. They finished early. Now, I don't want to say it's uncharacteristic for projects of this magnitude or many around to finish early or on time, but they did a good job at the park and they wrapped that up early. So that's pretty good. Let's see here. Anything else on here that you guys would like to know about? Everything else has pretty much been going on for a while now. The Nahuku lava tube restrooms are closed for rehabilitation January 12th through April 3rd. I know everybody likes to stop there. So you might want to make arrangements prior to driving down a little bit. And also finished early are the new boardwalk at the Silver Banks. So that's kind of exciting with their yellow cedar planks. There is our Maunaloa Road open. Work to drill into and sample material below the road finished a couple weeks early. That means motorists, hikers, and cyclists can again enjoy the historic roadway from Kipukapu'alu to Maunaloa Lookout 7 days a week. Surveyors will continue to work along the road, and motorists are urged to drive slowly and safely and obey all signs. If you've been up this road, you know that you don't drive fast anyway. We do have our friends at Hawaiian Volcanoes National Park presenting the 5th annual holidays at Kahuku going on down there. Since we don't have the After Dark in the park presentations going on at the visitor center, Kahuku is ramping up a little bit of activity. KK would love free face and painting and visit from Santa. A lively lineup of musical performances include Kipapa Sisters, Hot Potatoes, and the Southside Symphony. Food vendors include the Hawaiian Civic Club of Ka'u, 4 Scoops of Aloha, and more for free. That is Saturday, December 7th, 2024 from 9 until 3 p.m. It's a 6-hour event down there. And they also have coffee talk going on down there. If you are a bird nerd, retired park ranger and avid birder Jaybird Robinson will talk story about the native birds of Kahuku from Makai to Mauka, covering the seabirds, shorebirds, a few wetland and shrubland species, and of course the forest birds, part of the Kahuku Coffee Talk story series. That is on December 14th, 9:30 a.m. It's an hour and a half down at the Kahuku unit. I have gone to, we've actually live streamed one of these bird presentations. They're fantastic. These guys know what they're talking about. And if you love birds, check that out. I wouldn't miss that one. I actually was really into the seabird presentation that they had put on, I think maybe last year. The Civil Defense and the Leo TV have a youth media challenge happening. Agency is teaming up with the Civil Defense Agency is teaming up with Naleo TV for the 2025 Youth Media Challenge. Share your vision for a more prepared Hawaii Island through short film, PSA, or digital art. Submit your project by March 7th, 2025. And that is what they're looking for. Public service announcement, short film, digital art, disaster prep, media project ideas. If you are a youngster or you have a child that would be an aspiring filmmaker, check that out. I encourage you to participate. And also going on up at the park, I'm out of order here, but I always wanted to bring this back up because there aren't a lot of extra things going on up there. This is a free event. It's Life on the Edge. It's a 30 to 45-minute introduction to the summit on a short guided walk from the table at Waikahuna and multiple times throughout the day. Meet with a friendly ranger at Lake Kahuna Park, area conveniently located by the restrooms. Dive into a captivating, eruptive history of Kilauea volcano, where the earth itself comes alive with stories. That's every day, starting December 1st to December 31st. There's some multiple times. It's 30 minutes. It's quick, but I guarantee you those guys will probably keep talking for another hour. So enjoy that one. And the Pacific Tsunami Museum has the first Saturday free coming up this weekend on December 7th from 10 to 4. Enjoy the melodies of local musician Kanoa Fong performing live at noon. Get downtown Hilo and support the Pacific Tsunami Museum. I know we had that earthquake today that Phil was talking about, and everybody was anxious, weren't they, for a minute? And our friends at Haka, they're down at the Pahala Community Center. They're doing free microchipping registration and licensing fees are there down at the bottom. Saturday, December 7th. We actually brought down one of our friends' dogs down there and had them microchipped a couple weeks ago. That I threw in some of our pups, and these are our rescue dogs here. One of ours is ours, the other is some friends, just as a little something fun. And we are still going on our last week, I guess now, of our end of year fundraiser. Thank you to all who have donated. We're at $2,300 of our $5,000 goal. There's still time. The best way to donate to us is on our website at hveri.org/donate. If you're on Facebook, you can also sign up for a peer-to-peer challenge in there. That's also helpful. And anything donated is much appreciated. Your donation fuels our volcano education, digital resilience, and youth development programs. And with that, Dane.
Also like to just shout out the Kilauea Recovery and Puna Strong grants put on by the County of Hawaii and facilitated by the Hawaii Community Foundation. Their support really has helped a lot bringing this type of program together, as well as our other programs that we do at HVERI. I would like to thank everybody that tuned in today, as well as our donators which came through. We did have one from Benjamin, a $20 super chat, says pizza money. Merry Christmas. Appreciate that super chat there, Benjamin. And yeah, we also take them over on though, as Lou said, Hawaii Tracker or hveri.org/donate. There we go. And yeah, appreciate all the support and the likes, subscriptions, the shares, all that stuff helps as well. Yeah.
All right.
With that, I think we will. Yeah, we got a good amount still to go, so we should move on that. Thank you, Lou.
You're welcome.
And let's get Phil back in here. You're muted. Sorry. There you go.
All right, guys. So yeah, I did see a couple comments from our regular Yvonne Bauer that I thought maybe we should just mention real quick here. She's pointed a couple of things out. She's mentioned that she's been going out every couple of weeks and measuring temperatures and looking at the cracks. And she has noticed new cracks opening up near Kananui-Ohamo over the last 2 weeks, corresponding to these new increase in tilt and earthquakes as well. So it can be hard to say if the cracks maybe are new or if they just widened a whole bunch, but definitely cool to hear her report that. And as well, that the ground was so hot that her boots got hot over by Kananui-Ohamo. So that suggests to her that reservoir at the Maunaloa area that we reported from the escape road tilt meter rising and filling, she also reports it getting hotter as well. So it does seem like that all is consistent as well.
That's pretty hot.
Agree to have boots on the ground information, literally speaking there. So mahalo for that, Yvonne. We appreciate that from anyone that would like to give us ground truth at any point in time. Make sure we're being kept honest here. So mahalo for that. All right, so maybe we can move on to our Maunaloa celebration here.
Yeah, I think it's time. Go ahead and get into it.
We can celebrate since it all went fairly well in the end, right? But like at the time, it was a little hairy, it seemed like. We'll see how much of that we actually capture here, but that'll be our volcano awareness presentation for this week. And I thought I would start off just with that same image as it did in our preview. From Harry Durgan over Hilo Bay, you can see in the northeast rift fountains and the flows moving down, similar to that 1984 image we had of Maunaloa. That's famous as well. So Let me zoom that in a little more for you guys that have smaller devices perhaps there. So pretty cool view, and maybe capturing how impactful this was on us as a community and as a society here in Hawaii. We did cover that whole first phase, opening phase, the Southwest Rift Summit last week, or 2 weeks ago, I should say, on our celebration then. So today we'll focus more on that main phase, opening of the Northeast Rift, and the progress of the lava channel before it starts winding down around December 8th, 9th, 10th, somewhere in that range there, in the last week of the eruption or so. So we have here an INSAR image that shows that opening phase on a Northeast Rift. It was released by the USGS, showing exactly them picking up that location of opening. And what I'll show is this very first video, a video they have released of that. This might have been the second or third day after that fissure had opened up in Northeast Rift, and is feeding multiple channels of lava down towards the saddle with Mauna Kea in the background over here. So I'll show you guys a few more videos here from this phase to kind of help us all remember what was going on. So this is November 30th, and all the gas, massive gas coming out from the vent there, feeding the rivers down towards the saddle. The fountains are coming up from recent flows with very low cinder cone profiles around them. The flow fronts are spreading out, branching, and advancing steadily down the slope. This is a huge distance from that Northeast Rift to the actual flat part of the saddle. So we see the flow moving many miles, but still not getting near anything or anyone. The USGS goes out and starts deploying a ton of webcams. We have a bunch of webcams from this eruption. They're scrambling a lot. The weather was really bad the first few days. So a lot of this imagery that we have now was released after the fact. But we see here them setting things up, panels, batteries, cameras, all of that. And we know after the fact they came through and took things down periodically. And some of their batteries only lasted a week, so they'd come and switch them out every week, or in some of them they might have switched out after the eruption was all the way over as well. So there you see some of that initial scramble. This is really cool that we had that live camera at Maunaloa from USGS during all of this. And this is part of that effort here. There's them setting that up and using that new cell service setup they had figured out for emergencies here. And yeah, thermal views of their camera. This is that first phase where we're really first seeing the fissures and the flows moving down the hillside there, mountainside there. We're still near the rift on this image. You can see the old cinder cone at the top right there, so previous eruption site. And we ultimately had 4 different fissures, 1, 2, 3, and 4. And of those, they opened in that order, 1, 2, 3, 4. 3 became a dominant vent, but 4 opened after 3, so it falls into this pattern as well too. So here's that clip from December 1st from the USGS. We've had the fissures going for a few days now. The Northeast Rift, Fissure 3 here, sending out flows towards the saddle. Here's Fissure 4 coming in on the right side. A little bit of it right here. Maybe this is joining into. I'm not sure how they split these two up now. But early on, there actually were some flows visible on a ridgeline that actually could be seen from the Kilauea side from Hawaiian Volcanoes National Park. We'll come back to that in a few minutes. But first, let's keep looking at these short video clips of this phase of the eruption. There's a river of lava building its levees and moving through a well-established channel there. You can see a little sliver of island in the middle there as the flow splits around it. Here we have coming up the river to the source. You can see it was really windy. This camera's having some focus issues. But you can still get enough to see the massive amount of gas coming out. That long line of fountains, the lava pouring out the gap of the cone and rushing down the river down the slope. The cone itself, you see, is growing. We're starting to form these ridges where the spatter is falling to the side. You occasionally see the lava spatter out onto the edge of the cone as well. And those flows came down, and the first thing that impacted was the Maunaloa Weather Observatory Road. So you see here's one flow, and here's another coming down this way, and both branches crossing this observatory flow road. And these are power poles for scale here to give you an idea of the size of this thing. So I'm going to play that little clip here. Was that it? No, maybe there's a little more. Okay. And so the flow front itself maybe is not moving quite as fast as lava within a channel because it's spreading out and covering more area as it splits and branches from above. There is all kinds of different cameras and views, so we'll just pick some of these best ones. Here's the lava river coming down all these channels. You see it's like banking as it's moving around a slope. There are some rapids, standing waves occurring as well. And these kind of features became important for the scientists to measure the flow speed of the channel. And then from that, they could then estimate a cross-section, and from there, a flow rate, flux volume as well. Beyond deploying the cameras, they also went out to sample the lava. So here they are at one of the earlier fissures, looking for lava samples that had been thrown out of there. So all of that happening. Dan, you want to jump in with anything on these videos that sparks your curiosity?
Nothing yet. I mean, it's just cool to go back through it. It's, you know, amazing how much glare is up there. There's a lot of contrast, how bright the sun is and how black everything in the surrounding is. I remember 2018, capturing the lava was surprisingly difficult type of thing, with even in the daylight, at night, all the time. So when we kind of get spoiled on Hawaii Tracker with guys like Andrew Hara providing all this footage and all the photographers that are on there, right, that have been there for years. Too many to name. And they're really, you know, bring it up to just make it look so easy, right?
Yeah, for sure. Yeah. So, all right. We had that growth of the cone I mentioned here. And so here's a before and after from the 29th to the 2nd, showing you can see how much more fountain you can see early on that first day compared to 3 days later. We've built up this big hill around the fountains. And we have a time lapse of this occurring that we put together and released as well. So let's play this. Hopefully this will play. What is going on here? Reload. All right, let me try to find that again.
Of course, it's always, you know, when we're live, these things just crash.
That one was called the M5. Okay, there it is. Let's see if this works like that. All right, there it goes. Oh, was it starting at the end? No, maybe that wasn't it. Yeah, that's the wrong one here. Let's see if I can find it again here. Here we go, M5 cone. A wider view to start. And that cone growing there. Let's see if I can find the other one here.
You really see it at night growing.
Yeah, well, here it is. Here's the one I want. Zoomed in, you can see that growth coming up, all the spattering over the edges. You see little bits of collapse occurring. It still grows. You can see the data down there at the bottom left. So that was a pretty cool thing to see. I'm going to play it one more time again since I finally got it. There it is, growing up. Yeah, if I recall, those fountains were somewhere in the range of 60 feet tall, perhaps. So there are some multiple story hills here on the side of the fountains.
Right.
So yeah, that's the cone growth. We did have other webcams from Mauna Kea that first picked up views at sunset on the 29th. So there's one of those views right there. Zoomed in a little bit, it actually could see from that camera, but as they then went and installed more cameras, even on Mauna Kea as well, we ended up with better views of that. So first I'll show you guys a compilation of just some nighttime views. The daytime was a lot harder to see. There was a lot of weather through here as well. Some of that is clipped out. So to start off, the first image is really blurry because that's from the original really zoomed in wide view camera before that new one was installed. So, but this is the view of the nighttime with progression of the flows down that hillside there. So we see that fissure 4 on the left, fissure 3 is in the top right, setting those flows down. You can see different pulses of lava establishing new channels, overriding the previous channels, branching out. You can't quite see that pancake fanning out the bottom all the time because of this clouds blowing into the saddle right through here. But occasionally it does peek out. Right? This is a big pancake. Lava's feeding to this big pancake and spreading out in every direction there radially with this constant flow from above. See, by the 6th and 7th and 8th, we start seeing more pulsing, more breakdown of the channel. And so we'll pause our video and stop it right there. And we'll leave that section, the shutdown phase, that'll be next week. But just so you can see this whole phase, I really like this one. I'm going to play it again here. How this is really what all the maps we found out were drawn from. Well, this is really our primary data source for much of what we know was this static camera coming down, and a lot of detail you can see here, and a lot of the branching, and this is really fantastic time lapse, perhaps the best time lapse ever of Mauna Loa to this point. Eruptions.
Yeah, I don't think there's much competition really.
Yeah, it just hasn't done it in the last 40 years before that, right? So yeah, pretty cool. That's the nighttime view only. I do have a full version with the daytime as well. Maybe I won't play all of it, but I thought it's useful just to remind you guys because this is something that everyone was trying to go and see, right? So in the daytime, you actually could see some dust clouds rising, some glow, a lot of the gas coming out as well. It really was nighttime when everyone was flocking to the saddle to try to get viewing of this area. And I wasn't sure where we would talk about that, Dane, but this might be a good place, as good a place as any. If you want to intro and talk about the viewing area a little bit, what do you think you're going to save it? Oh, I can't hear you.
Yeah, let's go ahead and do that. So over the course of the eruption, we had several interviews with Mayor Mitch Roth and USGS scientist in charge, Ken Hahn. And in those, one of the conversation topics that we kept becoming reoccurring was the idea of a viewing area. So we went ahead and chopped all those out and be able to share with you today in a short little compilation. So maybe we'll play that right now.
All right. Yeah, sounds good.
I have a question for the mayor here. We had you on yesterday and we were talking a little bit about visitors coming to the island and trying to view the lava. And since then, we've seen Department of Transportation put out a release saying advising against the people parking on the side of the road on the saddle. So what's the situation with viewing the lava flow?
So yeah, we are also recommending people not park on the side of the road. It is a highway. There are safety issues. We have a lot of people that are driving too fast on that road as it is. So we are working with the state to arrange some places where people can view, where they can park. We're looking at possibly using a shuttle. Unfortunately, the county, other than Gillicuddy Park, we have no land up there. So we're looking at using Gillicuddy Park as a staging ground, but we're working with the state.
Yeah, so at that point, do you have any thoughts about that point? We're just, beginning the conversation. We're day 2. That was the day of day 2. So we're less than 24 hours in at that point when we're talking about it. Already beginning the conversation. But see, let's just continuing the eruption and things along those lines. What is considered kosher?
What is kosher?
Yeah,
that's a good question, Dane. They are closed the Maunaloa access road. We don't want people hiking up there because it's really not that safe. We are looking at also making some places for viewing. So, like, I don't know if it's the Gillicuddy Park, some of the other parks that are up there where you can pull off the side of the road safely.
We are opening up today a traffic hazard mitigation route, and this is to ease.
Yeah, so at that point, we're now into day 4 of the eruption, and we've had some conversations behind the scenes, right? Trying to get the viewing area, as we were calling it. And now we have an announcement. The mayor comes on the live stream to share it with us.
With the traffic on the Daniel K. Inouye Highway. So it's going to be just off of PTA property across from the Gilbert Kahele Park, excuse me, off of the highway. It's going to be a one-way route, and it will go in about 4.5 miles from across from the park, and it'll come out by by the Kipuka.
Yeah, so that was the first announcement of the viewing area, right? As we called it, where officially it was known as the traffic hazard mitigation route, because there was all this bureaucratic stuff that had to happen in order for the thing to even take place. But in reality, we all knew it was a viewing area, essentially. The mayor did what he had to do to make that happen. And so, yeah, we're just continuing now, still on day 4.
Question is this in place currently, or is there an opening time today for this?
You know, we've been shooting to open this afternoon. It could be as early as noon, but right now there's not much to see in the daytime.
Mayor Roth announced today the traffic hazard mitigation route.
All right, so this is actually day 4 as well. Ignore that day 6. But we then had Lieutenant Colonel Crowan from the Puʻuʻōʻō training area, the commander of the base up there, come on the stream as well and talk about what was happening with them in terms of trying to get the viewing area, which is on Puʻuʻōʻō training area property part of it, and the collaboration that was put between in order to make it happen.
To ease the congestion on Saddle, to deal with some of those responses you guys have had to deal with serious accidents on the highway. And we know it's a collaborative effort between you guys and the state and the county. Could you offer us some insight on that, how that process went?
Absolutely. So, like you said, started from a concern for our community who's trying to the law, which we can all absolutely understand. It's incredible. It's tough to put words to describe it, but they've been pulling over on Saddle Road, which is a very busy highway. And so working in collaboration with the mayor, Mitch Roth, and the state, we were able to develop a plan to provide a route and space for live viewing off of the highway, and hopefully, decrease the traffic accidents and incidents on Saddle Road. So.
And we were definitely having some stream issues that day. So if you're wondering why you weren't seeing anything, that was 2 years ago. We were just having system malfunctions those days.
Well, let's take our traffic hazard mitigation route. We've got up to about 17,000 vehicles that have gone through the traffic hazard mitigation route, which is quite a big deal, I think. And we were joking the other day, Philip, we owe a lot of that to you, because you laid down the gauntlet. Told me that, we talked about it in 2018, weren't able to do it. Within a day, we were able to do it. So good on you guys for doing that. We like these talks. It's like, oh, okay, how do we do it? Thing to do.
Right.
And Ken gives you credit, Philip, because he said that, we promised before we couldn't do it. So.
That was Dane, actually.
Oh, okay.
Either way,
right,
we work as a team. Had to leave that in there because that was kind of funny, and it was just part of the whole process, right? But yeah, we did end up pushing them on that, and it was a challenge that Harry Kim initially promised in 2018 to have a viewing area, to use one of the highways, to find a way to make it happen, and it never happened. And then with Mitch Roth, not only did it happened relatively quickly after we began, putting it out there that this needed to happen. So it was awesome to see that all come about, and to so many people to be able to go through the viewing area, the traffic hazard mitigation route, whatever you want to call it, go up to the old Saddle, and see Mauna Loa. Take your time and an legal, safe way.
Yeah, for sure. I think we should maybe should show the clip that we have from Lou that actually goes through the area, since we talked about it here. I think that might be cool to put that in at this point.
If you have it up, I would have to. It's going to take me a minute to get that up.
It's rolling right now. So
All
here we
right.
go. This is from Two Pineapples from Lou. Lou, you want to come on here and describe a little bit of what this was like for you to drive out there and spend all this time streaming and all of that? And share
Yeah,
all
it
this
was
views.
quite a impressive response to get that road built, because it was pretty tore up, and it was no joke. The highway was dangerous. People would back out onto the highway. So, big thank you very much for getting that put together, because probably saved a lot of people, a lot of agony. It was busy, it was packed, but if you just kept driving towards the end, eventually you found a spot, and it was a great road. I mean, honestly, compared to some of the roads here in Puna, wasn't bad at all. And the view,
And we're not going to always have that opportunity to be
Right.
able to have something with such a good view, so easy to access. Some of them are going to be rough,
Right.
Just nothing we can do, but when we can.
Mm-hmm. The challenge was definitely, like Mayor was saying, that daytime viewing was tough because the clouds would come in, the sun blocks the lava, so everybody pretty much was going up. We would get up there about 10:30 at night, 11 o'clock at night, and stay throughout the night in different areas, and it was nonstop. It was honestly nonstop. Even people we met and talked to that were going to work in Kona or going to work in Hilo would stop by there. It was a savior, definitely, to have that up there, including porta potties. So that's huge.
Yeah, for sure. Yeah, that was great. It was great. And yeah, thanks for having all this footage there. And man, yeah, that was the old, if you guys are not familiar with the area, that was the old saddle road before they made the Daniel Kaneohe Highway. So that road was kind of remnant already there, but not in use.
And you
then
might
we
think
would leverage
yourself
it
that,
for this.
oh, that road has just not been repaired in a long time. It had to have been in better shape than that back in the day. No, it was pretty bad.
It's pretty much like that.
It was pretty much like that.
Mm-hmm. Yeah.
You can imagine when this was the main island, main road connecting across the island. It was this one at one point in time, and not that long ago.
Yeah. And if you look on this drive here, I know we're moving through the time lapse here of it. There was pretty much, and places to park everywhere. The only thing I would say next time, and I don't know if this is even possible, to encourage people one way to park, either pull in at a diagonal or pull in straight. But that was the only real difficulty, other than, packing out your trash, which everybody pretty much did a good job of. But the parking, people couldn't quite figure out whether they wanted to park in at an angle or back in, or, head to toe. That was a tough one at some points.
Yeah, and that's part of why we like to look at this, is just so we have ideas of all the little details of things we can maybe do better next time, whether it's ourselves or issues we'll face as a community here. So yeah, so that was our little viewing area. Anything else in the viewing area, Dane?
Oh, I think that's it.
All right. Well, there's more to get through, so let's keep moving. And we'll see when we get to something else that fits in here. But I thought what I could show next was just a little bit of what we look at from Kilauea side. So here is a view from Hawaiian Volcanoes National Park, from, I believe this might be Genes Way. You can see here in the lower left, Kilauea's lava lake was still active. And up on a ridge is Mauna Loa's northeast rift erupting there. So the first time since 1984, we saw both volcanoes erupting at the same time there. And slightly different view here is from the tower at the USGS observatory at the summit, when it was still there before it was deconstructed, showing what that northeast rift eruption looked like during those early nights, when you actually could see on a ridge there those fissures fuming and glowing in the nighttime there. And from volcano side, a couple people actually reported to see a little flows trickling down to the south here, but it didn't last very long as the main flow went north and robbed all of that. So that's how it looked from Kilauea. So the next thing I thought we could talk about a little bit is just the mapping and how that kind of came out. I know we'll have something to talk about here as well, but early on, the maps were very basic, very crude. Right? Didn't have a whole lot of information. And so we tried to give them some context by just showing where they were, how big it was, how small it was, like how far it was from the roads, those kind of things, right? So here's one of those early views that we point out. Can't show you guys every single map, there's way too many, but there are a few things worth highlighting. Here's satellite views USGS released a little later on as they cycled through their different bands a few days into the eruption, where they finally had some view of what the footprint of this thing might actually look like. It took a few days for the clouds to actually clear for them to get these views, but when they did, this is what they came up with. So that's worth showing as well. And we have some better captures of these satellite data as well. Here's one that I like from Copernicus EU, right? They've enhanced the color a little bit there. And here's another one from our friend Cosme on Twitter as well, showing those two flows. And we have a couple versions of these maps iterating. So the USGS released early on these styles of maps. And so we have a few frames of what these look like in those first few days as they actually spread and propagated. That's it there. It wasn't a whole lot of those, but December 1st, 2nd, 3rd, 4th, 5th. So we're showing here. Right? And by that point, it was clear that most of the lava was feeding this one flow and everything else was stagnant. So we had a lot of contributors online, including Kit Tincher, who's a former USGS volunteer friend of mine, a housemate of mine. We both were volunteers at USGS together way back. And the reason that matters is he was actually part of this GIS effort on Maunaloa. And so he has these layers of all the different inundation zones, like where we think if lava goes into here, it's likely to flow this way. But if it goes into this side of the line, it's likely to flow this way. So early on, we're keeping a really close eye on which side of this line is that flow. And we didn't have the exact flow shape, just dots and approximate routes there, approximate paths. So when I did release those image maps, and we were able to put it a little bit more clearly in there, but you can see that there were areas where we're getting close to the boundary. We're wondering, is it going to go to the west? Is it going to go to the east? And ultimately, it was just going straight. It didn't go either way. It just parked itself before the highway there. But this was what we're worried about early on. Since it was a little bit hard to envision exactly where that was, I did pull out like this one that was highlighted from the soar.earth, showing this oblique view of where the Northeast Rift was, where the flows were compared to the other mountains, and Hilo would be way off the map down over here. So anyone who was really that worried about it coming towards Hilo, which it could have eventually done if it lasted forever, it could have gone all the way that way, which it didn't. But people in Hilo earlier on were wondering and asking questions about evacuating and all of that. So let's give them a better perspective of how far it was from doing that still at that point in time. We since have had the GIS layers released, and so Dane put this together. And Dane, you want to talk about this a little bit?
He'll be back in a minute.
Oh.
There he is.
I see.
Yeah, so this was just using the GIS data that was available in the final release by USGS on the Maunaloa eruption, and uses the timeline feature or the timeline layers and kind of plays it back day by day there. Also showing the Maunaloa observatory access road, and the yellow there is that traffic hazard mitigation route, the viewing area. So kind of showing the full extent, and also the purple that you can see in there, those are the actual fissures themselves. So you can see where they propagated and then the progression off of those. Thought it was cool to try and, give life to basically that time lapse that Phil was showing earlier, and try and show it in map form. So that was my attempt at that. All USGS data in County of Hawaii, as well as a little bit of created stuff in there.
Yeah, looks great. Yeah. Here's Observatory Road, as you mentioned, and there's 2 flows that we saw in that early video crossing that early on in the sequence. So pretty cool. So we have some videos coming up of that were released here on December 7th. This is probably be the last day that I'm going to cover in this segment here, but we have some video clips of different points. So here we have, there's a fissure in a channel, still pretty full at this point in time. Lava is charging down that chute. All among the recent overflows. So these are all lava flows of the same eruption, but now it's established this channel and it's carving its way in there, and mostly the lava is within that channel at a point in time. Now there's one. Here's another from the ground. And so you're watching these lava rafts floating down a river, and there's a great things that you can time to get a velocity of the lava moving within there. So there's that one, and another one from the ground is showing slightly fuller channel there. You can really see what the crust is all right up at the edge of the channel there, and just forming as we speak here. So it must be pretty close to that upper chute, upper vent right there. And if you look right straight across, it looks pretty fast right there. This looks like that's that similar spot where we saw, I don't have a video pulled up here, but in our previous video, we saw Frank Truesdale walking over here and taking a shovel of lava. Might have been from near there. And one last channel video here from the ground, someone following this crust, trying to, as it's zooming down the hillside there. Is that too fast? I think it might have been too fast here. Let's see, make sure this is, no, it's not normal, right? Well, it was just how fast it was moving. Some of the standing waves as well, and standing waves, knowing the viscosity of the lava, you can then make an estimate of the depth, and that depth combined with the flow speed and the width, the cross section, you need to get a full on volume. So that's how that'll work together. So those are the highlights of that phase of the eruption. I do have a few bonus ones, a few bonus time lapses as well. This is part of the few of the set that was released more recently, and it's similar stuff, but I'll play it for you guys. Here's the first one showing that vent and channel top there, and daytime view and nighttime view, what that looks like. You can see gas coming not just from the vent, but from the whole lava channel, especially in this upper section up here. A pretty impressive view there. Most of us were looking at it through the webcams to get these kind of views, and then from the viewing areas to get those wider angles, far away views with those big rivers coming down the mountainside being in the end over 10 miles long, right? I want to see if it's maybe 12 miles long in the end. And pretty cool here. Jump this forward a little and see next night, next night, next night. So these cameras go a long time, and we'll at some point try to release these in fuller format. But you see towards the end here, we're starting to get single fountains. We're starting to see the nature of the eruption change, and that's what where we'll pause the video. The lava channel level is starting to drop a little bit within here, and that's the evolution of that main phase there. So here's another one that's showing the onset of the fissure itself, right? So here we have 11:29. This is that very first morning, right? When we see that the fissures have just opened up. They've just landed, and these are some of the first webcams deployed. There's fissure 3. Where you see the flows increasing and spilling over and feeding some of these flows that are actually moving to the south over here. And pretty cool to have this one come out and see some of that early footage. And this is a fast version. I have not compiled the version that's extra slow because I knew we would probably be going along tonight. But still wanted to give you guys a taste of that and a slightly different view. You see that fissure wall building as well, building to that height of the fountains up there too. So just want to go a little bit further, catch this moonrise, and yeah, there is that second time lapse bonus from USGS release recently. A couple more. Here is one. It was recording on the point slightly later on the first. It's recording, and I put it in their pack, and I fly it in a helicopter, land it to look at the channel. Moved it, landed it again to look at the channel. Check out this channel at night, because this one is a nice view. You actually can see quite a bit of the surface of the channel moving through here. In the daytime, it's just kind of fuzzy through there as it moves, but let's see here. We see this is capturing images almost every second, but here we go. Here is nighttime. And we see a little bit better that movement of the lava, the crust, the glow coming through. So this one is super long, so I'll kind of jump it a little bit here. Just get a taste of what this actually looks like. See, like towards the end here, we're starting to form a little bit more rapids. Where to go right in here looks a little bit more rapidy, coming over the edge. And this is the point of them measuring, capturing all this, is to be able to use this data to do research on after the fact and all these years since and ahead. Well, it comes a little surge here. And you're starting to have surges coming through at the end, and the nature of the flow is changing. And yeah, we'll wrap it up here for this phase of the eruption. One more time lapse to go, but this is the date. We'll pause and stop right here as these pulses and surges begin coming down the channel. So the last one is also of Fissure 3. This one is quite a bit shorter, but there's that fissure opening, big flows, fuming foreground as well. Pretty cool to see that one. And it's even earlier on the 29th. See that's let's pause it here. 28th, 9 in the morning. See that fissure popping out there, dying off, settling down. That might have been that Fissure 4 moment, opening at Fissure 3 over here on the left. Pretty cool. And that wraps up the time lapses I had lined up, and looks like we're about on time, so we can discuss some more. What have you got more, Dane, to go to add in here? I can't hear you.
I don't know how much of that we want to go into, seeing it would probably take us way over.
Your call to if you have anything on the show now, or
let's just do the interview stuff, and then maybe we'll have Lou go through his footage next time, and just do a start to finish of all that Lou stuff that I have cut, because I do want to go through these interviews because they took a while to line up at least, and they play into the other interviews that we had going. So let's just, I guess we'll do that one, and we'll end with that one in terms of the stuff I want to show. And then we'll just Lou next time. It's the whole session for you. Of your footage.
Perfect. Thank you.
It's only about 10 minutes in total, but
yeah. I appreciate that.
Right. Yep, here we go.
We historically have these eruptions. They start at the summit, and they'll go into one rift zone or the other. They don't go into both rift zones. They don't jump between the rift zones. So it's not like it'll finish erupting on the northeast rift zone and then immediately go over to the southwest rift zone. The next eruption in Maunaloa, I mean, who knows how long it will take between this one and the next one, but could very well be on the southwest rift zone again. And I know people, originally saw those lava flows that were coming out of the southern end of the caldera. And I have to, make a distinction here between Kilauea caldera and the summit of Mauna Loa. The summit feature is much bigger. There's an older outer caldera ring fault, and all the collapsed pit craters in there lie within this bigger caldera feature. So when we talk about the summit, we talk about that. And there was a fissure that extended out of the caldera, but still within the bigger structure. And that was what put out those lava flows that people could see. The probability of it getting into Kaumana is pretty low, right? There's only been 2 historical flows of all the flows that have come down the Northeast Rift Zone that have made it in there. One of them was a year-long eruption, very different than what we're seeing right now. Not that this couldn't change and do that, but that there was only one eruption like that too. So we're dealing with really small probabilities at this point.
Yeah, so that was early on in the eruption. We had all three of them on there for a little bit, talk about what was happening, and we did that a couple times in the eruption. And it was just, I like the breakdown that Ken gives there. It's just so simple in terms of starts at the summit and then it goes into the rift zone. And once it gets into the rift zone, it doesn't go into the other rift zone. It's just from fact to fact, real easy. And then we sat down with our VMAP, our VOG mapping specialists. And this is some of the interviews from that, clips taken from that.
So in summary, we're going to talk about why forecasting models for VOG, like VMAP and others around the world, don't always agree with what we're measuring with our instruments on the ground. So like the Hawaii Department of Health network or the Purple Air network.
Yeah, we forecast VOG using numerical models. So they incorporate weather forecasts and kind of best state of knowledge about what the conditions at the event are. So with this new eruption, obviously this was a very new scenario for all of us. So we're forecasting something that's very different from previous volcanic eruptions that we've been modeling. Obviously there's lots of uncertainties, and I think we're going to talk about all the different reasons why something you're measuring at the surface might not necessarily be matching what the models output. So it's sort of like, people are used to precipitation forecasts, like POP, right? Probability of precipitation. And if it says it's 30%, you'll be like, well, maybe it will rain. And that's exactly the kind of forecasts we're displaying on our forecast page. It's like, well, how likely is something to happen? So you might see a lot of things kind of moving around, and it's not necessarily that there's a lot of VOG, just that there's how likely are they to occur?
And then another
So,
one from Lieutenant Colonel.
A couple days into the eruption, the lava flow
was that
crossed
muted?
A portion of our very southeastern boundary. Is currently flowing that area. That's the training area, and there's no danger to the cantonment area where the workforce works and resides at Puʻuʻōʻō training area, but they're still monitoring that very closely. And yesterday we were able to facilitate access to a team from USGS to get out there and take a look and help them with their assessment of the lava flows to help inform the overall assessment.
And I know people have always wanted us to put live cams out there, but our seismic data kind of takes the first bit of the highway. We got to make sure we get that. And the bandwidth has always been a problem. So we got this on a cellular modem. We put in a whole bunch of quarters into the meter, and we'll see how long it runs before we run out of data for the month on the plan for that. But those live cams take up a lot of data, and I know people have looked at Iceland, but the Icelandic live cams were put together by their TV station, their national TV station that had a satellite truck and everything out there. So the only other thing that could change is you could have a vent open up at a lower elevation on the northeast rift zone, but none of that will reach the folks in Kau and South Kona. So those guys, for this eruption, we dodged a bullet. It didn't go that way. What we can say is sometime in the future, it will go that way. Just not this time, right? So people can relax out there right now.
Yeah, so that last video we heard Ken talking about how everything was safe for South Kona and for Kau. That the only possible change might be a further event further down a rift. That's something we're considered about because that was what happened in 1984. That did not come to pass in the end. So that was that last video. The one before that was Lieutenant Colonel once again, Lieutenant Commander Colonel. Lieutenant Colonel Curran, and yeah, I think just recapping the collaboration and the viewing area there again. So
yeah,
it's great to have access to all those guys, and everyone was really working together. One of the key things was that eruption began its sequence at 11 o'clock at night on a Sunday, and so the there was no traditional media available for the word to get out. It wasn't like it happened at noon and it could just go live with the breaking news on Oahu. There was just no one around except for us, and that's why we benefited so much from that. And it's a good test case of really why that collaboration is necessary, more localized than relying on off islands and other people's schedules, that kind of thing.
Yeah, definitely. And being able to do it, keep up with the volcano with the pace of change that it can lead into, because we were able to let off the gas significantly on Maunaloa after it went into the rift zone on the northeast side, right? As Ken was saying, it doesn't then go into the southwest after it does that. So it's like, all right, so we just bought ourselves, as soon as it goes into the northeast rift, it's like we just bought ourselves a lot of time. In order to get to Hilo, we're talking about hundreds of days type of situation, as opposed to if it went southwest, we're talking about few hours to dozens of hours, it being really bad really quickly.
Right. Yeah, and that's really a good thing to kind of wrap it, tie it all together here, because that's why we're doing this, right? We know that someday that is going to happen. Ken mentioned that someday that is going to happen. It didn't happen that time, but we can come back to this only modern eruption of Mauna Loa, in this age of the digital world, and look back at how it went and anticipate what might be our sticking points next time, right? And work on those now in advance, because we have to be much more on it for a southwest rift eruption, as Dane says here. So yeah, that's good. I think that's most of the main phase here. I mean, there's obviously more of blues footage we haven't got to. We have that whole wind down phase of a lot of channels surging and pulsing and things collapsing, and vents start fountaining a little higher at some point, and then things wind down after all that. So that'll all be how we end the Mauna Loa celebration next week at a regular time, after catching up with Kilauea as usual, like we did today. So anything you guys want to? Yeah,
it might be worth also mentioning that we are planning to take the Christmas week off, unless something happens. You never know. That right now things are quiet, but if that would be the case, we would be taking what would be the 26th, no live stream, just like we did for Thanksgiving. Take a week off for that.
Yeah, and yeah, I might throw out. I'm actually going to be out of town past the following week in a second too. So we'll see. We might depending if nothing's happening. If it's really slow, we might even stretch to 2 weeks. We'll see.
Yeah, we'll see. Could always use a little.
We're
break.
always on call.
Right.
Yeah. Use a break. We're always on call. So that's how it works. All right, gentlemen, Lou.
That's interesting. There's the little comment from Marin. I'm just going to throw up here. It's what they said on TV in the California fires in the summer. Pay attention to social media. They're faster than us. At least they recognize, instead of out here when it was 2018 was the opposite. Don't pay attention to social media. Only listen to us. Type of thing. And then they turn around and go look at us to get their information. So it was like, what is this? But hey.
We've come a long way. We can talk about all that some other time. We've gone super long today, but that is the basis of our whole digital resilience program that we do today, and we talk about all the time. That's where it all came from. So we'll keep pushing forward with all that, and that's why we do this. That's our mission, to improve preparedness and the response here on Hawaii Island for any future eruptions, Mauna Loa, Kilauea, anything, right? So that's why we're doing this, and we appreciate all your support. And all of those of you guys who are stuck with us through our hour 45 minutes here to the end of our broadcast today.
We did have a $50 donation come in from Skagit Ed. Want to make sure I got that out there. Thank you much.
Mahalo, Ed.
Okay, yeah, thank you. Appreciate the support. Long-term viewer, long-time supporter.
All right, guys.
Yeah.
Yeah, let's wrap it up. And until next week, everyone, at our regular time, 5 p.m. Hawaiian time on Thursday, unless something happens before that, as usual, is our standard caveat. From our nonprofit, HVERI, the Hawaiian Volcano Education and Resilience Institute, I'm Philip Ong. Top we have Lou, and Dane right above me. Aloha, everybody.